This lesson is on section 4.4 titled Constant Rate of Change. This lesson is very similar to last lesson when we found the rate of change, but this lesson is based off of constant rate of change, which is also kind of referred to as slope, like I referred to in the last lesson. And the slope of a line is the ratio of the rise, so that vertical change, to the run, which is that horizontal change. So in this lesson, I'm going to give you some examples on where I'm going to give you a graph, and I'm also going to give you an example where I give you a chart, and you're going to have to find that constant rate of change or that slope of the graph. So the first example says, the table shows the relationship between feet and seconds. Is the relationship between feet and seconds linear, or is that relationship constant, meaning there's a constant pattern that is formed? That's what that word linear means. Is there a pattern that you see? And then if so, find that pattern or find that rate of change, and if not, explain why it's not. Okay, so we're just going to find a pattern here. We're going to look at the data for the seconds, and then we're going to look at the data for the feet and see if we can see some sort of pattern. Okay, so I look at the first data point, and we can look at this as this is the x coordinate of the graph, and this is the y. So if you were to graph this chart on a coordinate grid, you'd graph the point 5, 2, or 1, 1, or -3, 4, and so on. So let's look at the relationship between my x values and then the y's. So for my x values, I'm going to look at, so between 5 and 1, how do we go from 5 to 1? Well, it looks like I have to subtract 4. Okay. So how do I go from 1 to -3? It also looks like I have to subtract 4. Looks like I'm seeing some sort of pattern here. Let's see if this works for the rest. If I go from -3 to -7, it looks like, I'm going to subtract 4 again. And then from -7 to -11, I'm also subtracting 4. So I found a pattern. So far, it looks like that it is going to be a linear relationship, because so far there is a relationship between my seconds. Now is there a relationship between my feet? Let's see. So to go from -2 to 1, it looks like I have to add 3. Well, to go from 1 to 4, it looks like I have to add 3. From 4 to 7, yes, I have to add 3. And then from 7 to, this is actually supposed to be a 10, sorry guys. But from, as you can see, from 7 to 10, you have to add 3. So actually, we do have a pattern, we do have a relationship here, and so what we have to do is we have to find that constant rate of change, and that's really easy. So because we're dealing with feet per second, okay, so I'm going to put feet per second here, remember that's the division sign, okay, so it looks like we have 3 feet here, okay, because I'm just my pattern here, and then we have the -4 seconds. So we can look at that as the rate of change of -3/4 feet per second. Again, I'm going to say that again. It's the constant rate of change of -3/4 feet per second. So if you're ever trying to find a constant rate of change from a graph, you're just going to find the patterns between the x's, find the patterns between the y values, and if there's a pattern, then it is linear. So you could say yes, and all you're going to do is to write the rate of change, you're just looking at that pattern. So we found that the feet went up by 3 and the seconds reduced by 4. So then we have our relationship as -3/4 feet per second. So my next example is I'm given a graph this time. I'm not giving you a chart. I'm going to ask you to find the slope or that constant rate of change of the line. And if we can see, we know that this is going to be a constant rate of change because that line stays constant. It's increasing. It's going up at a constant rate. That line is completely straight at the same angle every time it goes up. So what I'm going to do is I'm going to look at the 2 points that I'm given. I'm given this point. I'm given this point. Now what I'm going to have to do is I'm going to have to find that rise over run. And I actually talked about it here. So we have the slope of a line is the ratio of the rise to the run. Okay, so what that means is I have to go from one point to the next. Oh, looks like it came off a little bit. Okay, so how much am I rising? And how much am I running? So how do I get from one point to the next? That's what you can kind of think of for slope. How much am I rising? And I'm rising, I'm gonna count. I'm rising 1, 2, 3, 4, 5, 6. So I'm rising 6, and then I'm running 1, 2, 3, 4, and I'm running 4. So to get from one point to the other, I'm first gonna rise, and then I'm going to run. And all I have to do is I'm going to take my rise divided by my run. It's as easy as this. So I'm going to take 6 divided by 4, and that's going to get reduced to 3 halves, or 3 feet per second. So because this y points are describing your feet, your x is describing your seconds. So our relationship is 3 to 2. So what's really nice is using this method is on a graph, or if you don't like this rise over run method, we could have looked at this point. We could say, okay, well this point is let's see, -1, -4. And then this point here is, let's see, 1, 2, 3, and this is 2. Okay, so we can use what we did in the last lesson by finding that rate of change, where you can subtract the y's and then subtract the x's. So what I can do is I can subtract my -4 minus 2, and then -1 minus, I'm sorry, I wrote that wrong, -1 minus 3. So then I'm going to get -6 divided by -4, and that's going to reduce to +3 over 2, because a negative divided by a negative makes a positive, and 6 divided by 4 reduces to 3 halves. So if you notice, these are the exact same. So you can choose to use the rise over run method when finding the constant rate of change, or for finding that slope. That's what I really prefer. But if that's a little confusing to you, you can always use that rate of change formula where we subtract the y's and then we subtract the x's to find our slope or our rate of change. So that brings me to the end of this lesson. Thanks for watching.